This is Mrs. O'Neill for AP Chemistry, your summer assignment answers. This is a little checklist for you. So as you go through the video, pause the video to check your answers. Of course, make any corrections, and then write down questions you have in the margins that you can ask them to me or another classmate the next time we have class. Then obviously continue playing the video, and you're either going to hear my words or I'm just going to kind of click through the PowerPoint so you can get through the answers. So also join Remind if you haven't done so already, and information is on your cover page of your summer assignment packet. You should have watched the video on significant digits. You should have also, for letter A, come up with the equation or the formula for percent error, and then looked up the actual density of gold, which is 19.32 grams per milliliter. And something else I want to bring to your attention is that 1 cubic centimeters equals 1 milliliter. So those are one of the same kind of unit, but they are used interchangeably throughout the chapter, throughout the course, throughout the textbook, throughout all of the AP exams. You should have then watched the 5 parts on significant figures and then did some practice. Now, the practice problems I can't put on here because for everybody they might have been slightly different. So if I didn't make any notations on your packet and you want me to check over your answers, I will gladly do that. Notice for this guy, for 40.002 grams divided by 1.3005 times 10 to the negative 9th grams, since you have grams divided by grams, there is no unit in that answer. You should have then watched the video on factor label method, and it's just a way of converting units and canceling out those units that are on the same top and bottom. You also want to remember that conversions such as 1,000 milliliters to 1 liter or 12 inches equals 1 foot, they are exact numbers, so they are not included in determining the sig figs in your overall answer. Take note here, density, however, has a different value per substance. So every substance has its own density value. Therefore, it still can be used as a conversion. However, it's not an exact number. Therefore, it can be included in determining the number of sig figs. So I did that purposely here where I started out with 25.00 milliliters, which is 4 sig figs, and I'm using the density of 0.789 grams for every 1 milliliter. And since 0.789 has 3 sig figs, your answer can only have 3 sig figs and not the 4 from the 25.00. Then you should have watched the video on matter. There are 3 ways to measure volume. One is with a liquid using graduated cylinder, and you have to use a graduated cylinder, not a beaker or an Erlenmeyer flask, to get a more accurate measurement of that volume. Then the other 2 is just a normal solid that you can measure the length, width, and height. And the other one would be an irregular solid, and you would use the water displacement method. This is also on your reference sheet, the Celsius to Kelvin or Kelvin to Celsius. So that's going to be on your reference sheet, but something easy to remember, that 273 number. You should have watched Properties of Matter. History of the atom. Take note, not only did we label the parts of the atom, but the appropriate charges. In other words, the electron is negative, proton is positive, neutron is neutral. The nucleus overall has a positive charge, and you want to know the difference between those energy levels and the electron cloud. Atoms and the periodic table. Take notice tin versus tin 2. Tin would just be the normal element. However, tin 2, I'm giving you a specific ion. So we want to remember that tin 2 would have a positive 2 charge, means that it lost 2 electrons. And for chlorine, it's actually going to change to chloride, have a negative charge because it gained an electron. A tour of the periodic table. So there are 18 groups and 7 periods, and we want to remember that these last 2 rows down here are part of period 6 and 7, which I believe is a question coming up. There it is. The bottom 2 rows are also parts of periods 6 and 7. Then you needed to watch the drawing of these Lewis dot diagrams. We want to remember that groups 3 through 12, those valence electrons vary because those metals have multiple charges. So sometimes they lose 2 electrons, sometimes 3, that same element. So it really depends. These are just the valence electrons of those elements. Now here we have a compound with nitrogen and 3 hydrogens. So we want to remember that there's a bonding pair and a lone pair. And again, we're going to refer to the bonding pair of electrons and the lone pair of electrons. And if it's an ion or a polyatomic ion, you also want to include the charge that's associated with that Lewis structure. Sometimes you can write things many different ways. So here they're showing you different dots and X's to show the different valence electrons from each of those oxygens. And you can also, again, include bars or dot lines to include the, or to represent the bonds. And I will tell you that the AP people who grade the AP exams want to see those electrons, want to see the outside electrons even if they're not bonded. So even though this is technically correct just to show the 2 bonds or the double bond between the oxygens, they are going to want to see those lone pairs of electrons. We're going to learn about bond angles in this course. We're also going to learn about formal charges in this course. You should have watched chemical bonds, covalent versus ionic. There are 4 main types, but then there's going to be branches off of them. So this flow chart is really nice to show all of that information that we're going to be learning again in this course. This is a nice question because it's a question right from an AP multiple choice. So hopefully this makes sense or you got the right answer. If not, something to think about. The closer the atoms are, the closer the elements are on the periodic table, the more non-polar they are. So take a look at where those elements are on the periodic table, and the closer they are within each other, the more non-polar they will be. Another AP question. Naming compounds. I like to remember this as Cliff H. Braun. Physical and chemical changes. Another AP exam question. Beginner's Guide to Balancing Equations. Mole conversions. Remember that mole map. This one was a little tricky because you had to go above and beyond just calculating molecules. You had to also calculate how many of those magnesium atoms are in one of those magnesium nitride molecule. Limiting reactants and percent yield, stoichiometry, all the way through the course. So my game plan would be to find the limiting reactant by calculating the least amount of moles of that product. From there, I can finish the problem finding the grams. So first, find that limiting reactant. You're basically doing a stoichiometry problem twice. Grams of this guy to moles of this guy. I'm sorry, grams of this guy to moles of this guy to moles of this guy. And then for bromine, same thing. Grams of bromine to moles of bromine to moles of this guy. Whichever one gave you the least amount of moles, then you're going to finish the problem. So you should have done that. And the C6H6 is going to be your limiting reactant because it gives you the least amount of moles as a product. Then you're going to finish by using the amount of moles and then the formula mass to give you that answer. So make sure you can do this because stoichiometry is really, really important all the way through the course. There's a difference between percent error and percent yield. Percent error, you want as close to 0 as possible, and percent yield, you want as close to 100% as possible. Another AP exam question. Acids, bases, and pH. And this is going to be a reaction. This carbonic acid is something we're going to talk about quite often. I'm giving it the equilibrium equation symbol, so we'll talk about that as well, about how this is a dynamic equilibrium. And we're going to talk about how it decomposes very quickly. Carbonic acid really doesn't exist because it breaks apart very quickly into carbon dioxide and water. So we're going to talk about how it's also at equilibrium because that carbon dioxide and water can really shift back and make more of that weak acid depending on the situation. So this is really what happens in a can of soda. Another AP multiple choice question. Hopefully this makes sense, and if it doesn't, again, hopefully you'll have some questions for me, but we'll learn a little bit later on, closer to the end of the course, that again, the 2.3 obviously is going to be a stronger acid, so X is going to be your strongest, and that's why it's at the end. So now why is Z weaker than Y? Well, if we look at the molarity, you need a heck of a lot more of Z moles in order to get to that 2.8 pH. You know, you need more moles of those H pluses to get it to more acidic. So that's why the Z is going to be the weaker than the Y. Water, a polar molecule. There is a difference between the covalent bond of the hydrogen and oxygen within the molecule and the hydrogen bond between the O and the H between molecules. So there is a big difference between bonds and hydrogen bonds. I really don't like how they call a hydrogen bond an actual bond. It's actually going to be an intermolecular force. And there's a whole chapter 11, in fact, when we talk about IMS, and hopefully it'll be a better understanding of why hydrogen bonds are really not bonds at all. I really like this picture because it's really neat to see how cold water is actually more dense than warm water. Okay, these are more dense than warm water. And again, looking at those molecules, you can see that those molecules are getting closer together. But as they get so close together and form ice, or H2O in the solid phase, they actually spread themselves out and they become less dense than water itself. So I actually think this picture is pretty cool to give you a nice visual as to what's going on with these H2O molecules. Another AP question. And that's a continuation of that one. And hopefully you have those bold polyatomic ions memorized. Okay, we'll see you in class, and I'm hoping to answer some of your questions.